All right, now we're going to simplify some radicals that have some variables, some letters in them. So this is actually, there's some tricks to this to make it so it's not so hard. So notice they just want you to they point out that x times x is x squared. So basically, they're telling me what was squared. So when I take the square root, it just goes back to x. Okay, so also there's one other, we're going to teach a little trick. Here's what the trick is. We're going to teach it a few lessons later, but we can write, we can switch things from what we call radical form to exponential form. So if it is written as a radical, I'm going to write root here. That index right here, we're just going to rewrite as the root. There's some number, we'll call it the base to a power, but you can rewrite this in exponent form as the base to the power divided by the roots. Just remember, roots go into the ground. So roots are on the bottom, our power divided by our root. So in this case, there's an invisible second root right there. Remember, if there's not a root, it just means it's a second root. So when I was rewriting this would be the 2 over 2 power, which 2 over 2 is just 1. Okay, so that's going to help us a little bit when we get over here. If you've got the same power as the same root, it just goes to an x. Same power, same root goes to an x right there. So when you look at this, it's not too much, it's not different than what we've been doing before. We're going to still make, this is a product right here, a squared times b squared. So we can split it up and just take the square root of both of those individually. So again, since a is squared, when I take the square root of that or unsquare it, I'm back to just plain a to the 2 over 2 power. Same thing with b, the square root of b squared is just b. So square root of a squared b squared is just plain ab, no more square roots over there. All right, let's try another one. Now this one, we're going to have to take a few products. Okay, we're going to make this into lots of products. Now remember, let's go back and just remember our numbers. 8 is not a perfect square. I cannot take the square root of 8. Okay, but I can write 8 as 4 times 2. Being that 4 is a perfect square, that's going to help me simplify that. Okay, I'm going to give you a hint here. When it's a square root, I want my x's or my y's, any variable, with powers that are multiples of that root. So I can leave this as x to the 4th power. But this y right there, y to the 5th, I don't like that y to the 5th because I can't divide 5 by 2. So I'm just going to subtract 1 from it and write it as y to the 4th times y. Then I still have y to the 5th, but I just have written it as a product now. So again, all I did was I took this 8 and I turned it into a 4 times 2, left the x to the 4th, and the y to the 5th is just y to the 4th times y. All right, now we just go ahead and split all of these up using our nice lovely radical property. What is the square root of 4? Well, it is 2. What is the square root of 2? My classes keep telling me nothing, but it is something. It is the same something. You can't simplify it, so it just stays the square root of 2. All right. What is the square root of x to the 4th? Now remember, this, since it's a second root, you can just do power over root, or 4 divided by 2. So you just take always, when you're doing the square root, it's just half of that. So the square root of x to the 4th is x squared. And the square root of y to the 4th is y squared. However, we cannot take the square root of y. This is not squared, it's not a power of 2, so we're going to leave that y under the square root right there. All right, now our last step is to simplify this, kind of combine everything together. Anything that is not under a radical can be multiplied together. So we can multiply this 2 times x squared times y squared, and that's just how we write it, 2x squared y squared. And then anything under the radical, just like we could split it up over here, we can also smash it back together. Okay, so anything under the radical can just be multiplied together under one radical. And there is our final answer. Not too bad, huh? All right, let's try this one. This one is now a cubed root. Okay, so again, here we're going to remember, we're going to want our variables in the powers of 3 or multiples of 3. All right, so when I'm doing this, remember from our list, you guys probably have it. I don't have it right up there, but 1 cubed is 1, 2 cubed is 8, and then 3 cubed jumps clear up to 27. So the 16 is not on my list. It is not a perfect cube right here. So I'm going to rewrite this. Now notice 8 really is our only option here. And luckily, 16 is 8 times 2. We're going to put a negative right there with the 8 because I can't take the cube root of a negative number. And then we're going to go ahead. M to the third is okay. That's a multiple of 3. But n to the fifth, we're going to write as n to the third times, now to make 5, I need another 2 n's multiplied together. So 1, 2, 3, 4, 5 n's multiplied together there. Okay, let's go ahead and take the cube root of all of these. Cube root. I just want to make sure I'm going to remember to do the cube root. All right, the cube root of negative 8, since the 2 to the third is 8, the cube root of 8 is 2. And then with the negative, it just gives you a negative 2. So negative 2 times negative 2 times negative 2 gives you that negative 8. Now, we can't do anything with that cube root of 2. You cannot simplify that at all. It's just right there. 1 isn't going to make any difference. The cube root of m to the third, anything to the third power third root, it just basically, if you cube something and then uncube it, it just turns back into an m. Same thing here with that n. These are all multiplied together. And then right here, since 2 doesn't divide nicely by 3, we're just going to leave it under the radical right there and write the cube root of n squared. All right, super. Now to clean it up again, just multiply everything outside of the radical together. So we'll have a negative 2mn, and then anything under the radical, the cube root of 2n squared. And that is us finished with that problem. All right, we're going to do the last 3 examples in our next video. So come back soon.